Hey class, this is lesson 3.3. What we're going to do here is learn how to use multiplication or division to solve inequalities. Here's the review. Why don't you go ahead and do that, pause the video and check back for the answers. Okay, so this inequality symbol is all numbers less than 2. And if we reverse that, we get 2 is greater than all numbers. The solutions don't change. It's just the way it's said. So in the first one, all numbers that are really smaller than 2. In the second one, all 2 is greater than all numbers. Consider the inequality 4 is greater than 1. Copy and complete each statement outright by replacing each box with less than or greater than. And answer this question: what happens to the inequality symbol when you multiply each side by a positive number? What happens to the inequality symbol when you multiply each side by a negative number? Justify your reasoning. Go ahead and pause the video, fill in the answers, think about those questions, and then restart the video. Okay. If we multiply both sides by 3, so remember we started with 4 is greater than 1. If we multiply both sides by 3, then we get 12 and 3, so we still have greater than. If we multiply both sides by 2, we get greater than. 8 is greater than 2. If we multiply both sides by 1, we get greater than. 4 is greater than 1. If we multiply both sides by -1, we now have -4 and -1. Well, -4 is less than -1. -8 is less than -2, and -12 is less than -3. So you should have noticed that as long as we are multiplying both sides by positive, as shown in this group, the inequality symbol was the same. But when we multiply both sides by a negative, the inequality symbol was reversed. We're going to use that idea to help us use the multiplication and division properties of equality in this lesson. So here's the important concept. If you're multiplying both sides of an inequality by a positive number, leave the sign the same. That's basically what this says. If A is greater than B, then A times C is greater than B times C if B is greater than 0. If A is less than B, then A times C is less than B times C if B is greater than 0. So notice the signs did not change with positive numbers. So if 6 is greater than 4, then 6 divided by 2 will still be greater than 4 times 2. And you can see that's true. 3 is greater than 2. If 2 is less than or equal to 3, then 2 times 5 will be less than or equal to 3 times 5. 10 is less than or equal to 15. If 12 is less than -9, which is true, then -12 divided by 3 will be less than -9 divided by 3. Because -4 is less than -3. All right? When you multiply each side of an inequality by a negative number, reverse the direction of the inequality symbol. So if A is greater than B, and A times C will be less than B times C if C is less than 0. In other words, if C is a negative number. And if A is less than B, then A times C will be greater than B times C if C is a negative number. And that's also true for division, because division is really just multiplying by the reciprocal. So In this first problem, we have 6 is greater than 4. If we divide both sides by -2, we have to reverse the symbol because now we have -3 and -2, and -3 is less than -2. If we multiply this inequality, 2 is less than or equal to 3, both sides by -5, we have to reverse the symbol because we now have -10 and -15, and -10 is greater than or equal to -15. The last thing, we're starting with the inequality -12 is less than -9. We're going to divide both sides by -3. When we do that, we have to reverse the symbol because we now have 4, and 4 is greater than 3. So if G is less than H and K is less than 0, then G divided by K will be greater than H divided by K. We reverse the symbol. All right, we'll put that to work here. So we have this inequality, x divided by 12 is less than -3. To find the solutions, we're going to multiply both sides by 2. And when we do that, when you multiply both sides by a positive number, it does not change the sign. We're going to simplify that, and we get x is less than -6. And then to graph that, we do not want to include -6, so we're going to do an open circle at -6. And we want all numbers that are less than that, so we're going to shade to the left of that. All right, go ahead and try problem 1. All right, see if you did it right. You should have noticed that since you're multiplying both sides by 8, you do not have to change the sign. So leave the sign the same. Just solve the inequality by using the properties of inequality. We'll do this in class tomorrow. All right, problem 2, what are the solutions to -2/3 W is greater than or equal to 2? All right, so the way we're going to want to solve this is we want to multiply both sides by the reciprocal of -2/3, which is -3/2. So I'm going to multiply both sides by -3/2. And I just multiplied both sides by a negative. That is going to make the sign reverse. And then I'm going to simplify this side. We get 1W. And over here we get -3. So my solution is all numbers that are less than or equal to -3. So I'm going to include -3, put a solid dot on -3, and I want numbers that are less than, they go this way. Okay, now that was something kind of new, so I think I'm going to check my solution here. I know that my boundary point is -3, so I want to make sure that if I substitute that into the equation, that it solves the equation. So -2/3 times -3, that's a negative times a negative, which is a positive. And 3 divided by 3 is 1, so I end up with +2 is equal to +2, so that checks. I also want to check one of my solutions, like -4, see if that makes it true. So -2/3 times -4, make sure that is greater than or equal to 2. Well, that's -2/3 times -4 is +8/3. And is that greater than or equal to 2? Yeah, because 6/3 is 2, so 8/3 has got to be more than that, so that checks. So I'm good with my solution. Go ahead and check. Do problem 2 and check back for the answers. When checking my solution on this one, I noticed I made an error. I changed the symbol here, but I wrote the original symbol right there. So the solution is all numbers greater than 3. So I want to check a number greater than 3, like 4. And so I end up with negative 4/3. And is that less than negative 1? Yeah, negative 4/3, which is negative 1 1/3, is less than 1. So my solution is correct. Now it's a good thing I checked it. All right. Division property of equality. All right, here's key concepts, division property of equality. Pretty much the same as multiplication property of equality. If you divide by a positive number, then you don't have to change the sign. And if you divide by a negative number, you do have to reverse the symbol. So let's put those ideas to work here. Problem 3, a cheerleading squad earns $5.50 per car washed. How many cars does the squad need to wash to earn at least $77? Let's let W equal the number of cars washed. And then the inequality, they get $5.50 per car washed, so $5.50 W, and they want to earn at least means greater than or equal to $77. We're going to divide both sides by $5.50. And if we divide that out, we get W is greater than or equal to 14, which means they must wash at least 14 cars to earn that amount of money. Go ahead and do problem 3. Check back for the answers. So we'll solve this inequality. And we can see that the number of cases that they could buy with $50 has to be less than or equal to 4.68 rounded. But that means they could buy 1 case, 2 cases, 3 cases, 4 cases, but not 5 cases. All right. What are the solutions of negative 5a is greater than or equal to negative 20? This one, we're going to divide both sides by negative 5. And when you divide both sides of an inequality by a negative number, you have to reverse the sign. So we get a is less than or equal to negative 4. Negative 4 is included, so I'm going to put a solid dot on that. And I'm going to shade all numbers that are smaller than negative 4, just to the left of negative 4. I might want to check that by maybe trying one number, like negative 5. So if I do negative 5 times negative 5, to check to make sure that that works in the original inequality. Make sure that's greater than 20. Negative 5 times 5 is 25, and that is greater than or equal to 20. So I seem to have the right answers. Go ahead and do the got it, problem 4, and the lesson check, and I'll give you the solution.